Hey Andrew, so to answer this question, you're gonna want to use the, one second. Here we go. You're gonna want to use the Q equals MCAT equation. So for our Q value, Q is represented by heat, which is usually followed by the unit either joules or calories. In this case, we want to know, what is it, the change in temperature. So let me just rearrange our equation real quick. Delta T equals Q over MC. So nowhere in the problem are we told a Q value. However, we do know mass, which is given to us over here. The only thing is we do have to convert that to grams because our specific heat capacity uses grams. So 0.5 kilograms, 1 kilogram, 1,000 grams, those cancel, giving us 500 grams. We are also given the specific heat capacity for tungsten. That's up here, the 0.13. So we'll just put this here, 0.13 joules divided by grams times degrees Celsius. So we are left with the dilemma regarding our Q value. We don't know how much joules or calories tungsten lost when it was dunked into the water. So let me draw out something real quick. So let's say we have our water. And this is our piece of tungsten. So our tungsten has some amount of heat associated with it. We're not given its temperature, but we won't be needing it for this problem. So the problem says that the 0.5 kilogram of tungsten was dunked into 500 milliliters of water, and we're told the water's temperature increased as a result. So let me redraw my diagram real quick. So if we are told that the tungsten was dropped into the water and as a result the temperature of the water increased, we can assume that heat came off the tungsten and was absorbed by the water, meaning tungsten lost heat, meaning we can assume our Q value up here is going to be negative. So I can't remember which law it is, but one of the laws says that energy can't be created or destroyed, it can only be transferred. So one thing we can now tell ourselves is that any heat gained by the water was lost by the tungsten. So we can calculate how much heat the water gained. We can use that as our Q value. And all you're going to do is the Q equals MCAT equation again. So we want to find out Q. So let's see if we have everything else. We know the mass. This is something you have to memorize. Here we're told 500 milliliters of water. You had to know that 1 milliliter of water equals 1 gram of water. and that's our mass, 500 grams. One other thing you just have to memorize is that the specific heat of water is 4.18 joules per gram degrees Celsius. And last, we need to change the temperature, which we're told here, 5 degrees Celsius, positive 5 degrees Celsius. So we're going to just punch this into a calculator real quick. 500 times 4.18 times 5, 10,450 joules. So now we have a Q value we can work with, because we know that this heat was absorbed by the water from the tungsten. So our Q value that we'll be putting here is going to be the negative of this. And the reason it's the negative of this is because the tungsten lost that heat. And for water, it gained it. That's why for water, it'll be positive 10,450 joules. For tungsten, it'll be negative 10,450 joules. So I'm just going to take this and bring it down here to finish the math. So our delta T equals negative 10,450 joules divided by 500 grams times 0.13 joules gram degrees Celsius. And then it's just going to be a matter of putting this guy into the calculator. 500 times 0.3. That's it. Wait, let me check something real quick. Yeah, that's right. Alright, so we now know what our change in temperature is. It is negative 161 degrees Celsius. So I made up numbers for this case. You'll never get an answer that's that huge, but that's how you'll go about it. So you'll notice that the big thing right in this problem, let me change it to a different color I haven't used yet. It was just making use of Q equals MCAT. First, when we use Q equals MCAT, we didn't have a Q value we could use right away. So we had to use concepts to find out how we can discover the Q value. And we know that energy is not created or destroyed, it can only be transferred. So since we know how much Q was gained by the water, we know how much was lost by the tungsten, which we figured out here. Feel free to send me any questions if something I said here was vague or if I did anything wrong while going through the steps. Best of luck, and again, feel free to send me any texts.